Hi guys, I welcome you to my YouTube channel, and today I'll be solving multiple choice questions. This is Physics 9702, paper 1-1, October, November 2022. Without wasting time, I would like to take you to the question paper. So we are starting with 1-1. I will solve 1-1, 1-2, and 1-3 because normally these are totally different papers. So I'll not go through the instructions, they are the usual instructions, but it's always good for you to go through them. You can go through the constants, the formula, the constants provided. I'll just straight go to the first question. So what is needed to accurately represent all physical quantities? Physical quantities can be vectors or scalars. Whether vectors or scalars, they should have a unit, and whether vectors or scalars, they should have a magnitude. So the answer is going to be automatically C, because the physical quantity can be vector or a scalar. But whether it is a vector or a scalar, it should have a unit and a magnitude. So the answer here is going to be C. Now, what makes D not correct? Some physical quantities do not have, may not be expressed in SI units. So an SI unit is not necessary for the quantity to be a physical quantity. A quantity is said to be physical because it can be measured in some way. So it has a numerical magnitude and a unit. So if it can be measured in some way, then it has a unit and a numerical magnitude, then it is going to be called a physical quantity. A voltmeter connected across a resistor in a circuit reads 3.6 volts. What could be the current in the resistor and the resistance of the resistor? So using V equals to I times R, remember V should be 3.6. So I'm just going to look for a pair that gives me 3.6. So 3.6 is equal to I times R. So I'll just pick my calculator and check which one of the pairs gives me 3.6. So I'll start with the first one. 150 exponent minus 3. That is the current times 0.24 kilo, it is exponent 3. So this is 36, so this is wrong. I'll check the second one. The second one is 15 millis exponent minus 3 times 2.4 exponent 3. 36, so this is out. I'll check the third one. 1.5 exponent minus 3, then times 0.24 exponent, because mega is power 6, so it's exponent 6. So that is 3 sixes, so that is also out. I'll check the last one, but I know it's the answer. 15 exponent minus 6, that is micro, then times 240 kilo is exponent 3, which is 3.6. So the answer is D. In an experiment to determine the acceleration of free fall g, the time t taken for the ball to fall through distance s is measured. The percentage uncertainty in the measurement of s is 2%. The percentage uncertainty in the measurement of t is 3%. The value of g is determined using that equation. What is the percentage uncertainty in the calculated value of g? So because there is division, there is a power, so it is simply going to mean that percentage uncertainty in G is going to be, I'll ignore the coefficient 2, so it will be percentage of S plus twice percentage of T. This 2 here is the power of T, so it will be twice the percentage of T. So this will be 2 plus 2 times 3, which gives us 8%. So the answer is going to be C. Which quantity is a vector quantity? Of course, here momentum is a vector, speed is a scalar, temperature is a scalar, Young modulus is a scalar. So it's only the momentum which is a vector quantity, because the momentum of a body acts in the direction of the resultant force on the body. A particle accelerates from rest, which means initial velocity is 0. The graph shows the variation of velocity v of the particle with the time t. Which graph shows the variation of the velocity v with the acceleration a of the particle? So we want a velocity against acceleration. This graph is of velocity against time. It is a straight line, which means the acceleration is the gradient, remember? And a straight line here means the gradient is constant. So as the velocity increases uniformly, the acceleration should be constant. So if it is a graph of velocity against acceleration, that means it should be a vertical line. So this one is not correct. This is not correct. This one means the velocity is constant, but not the acceleration. So this one means the velocity, as the velocity increases, the acceleration is constant. So the answer is D. The acceleration should be constant because the acceleration is the gradient. So this means the value of A is remaining at the same value when V increases. The graph shows the vertical velocity of a parachutist during the first 20 seconds of her jump. Approximately how far does she fall before opening the parachute? So let's look for where she opens the parachute. So for opening the parachute, the velocity starts decreasing. And the velocity starts decreasing at this point here. So this is the point for opening the parachute. Opening is here. Why is opening at this point? Because the velocity is now starts decreasing. So opening the parachute is there. So we want to find how far. This is going to be distance. And distance is equal to the area under the graph. So I'll first find, because distance is the area under the graph, I'll first find the whole of this area and I'll subtract, let me just draw a tangent here. So I'll just remove some tangent. Let me just move off, subtract off some tangent here. Because I'm just looking for an approximate value, so I'll draw a tangent here. So I'll first find the total area of the rectangle, which is going to be, I think this is 17. No, it's 13. So the total area is going to, I said distance is equal to the area under the graph. So the total area is going to be 60 minus 13. That is the total area of the rectangle. Then I subtract this part because I only want the area in this part here. So I'll subtract this. I'll just approximate this to a triangle because after it is approximately. So minus a half times, so the base will be this one here, which is, I think that is 7, and the height is 60. I can approximate the height is 60. So this is going to be 60 times 13. That is 780 approximately minus, I'll just say 30 times 7, which is 210. When I subtract 780 minus 210, that is 570. So it means this area here is approximately 570 approximately. So the answer here is going to be automatically B. What is the definition of linear momentum? Of course, we know momentum is mass times velocity. So without wasting time, mass times velocity, there is no product of mass and velocity, that is C. A mass of 0.2 kilograms is suspended from a lower end of a light spring. A second mass of 0.1 kilogram is suspended from the first mass by a thread. The arrangement is allowed to come into static equilibrium. Of course, when it is in static equilibrium, it means the resultant force or the resultant tension in the spring is going to be the sum of the two weights. So in static equilibrium, let it be before. Before, so it means the force, the resultant force or the tension is going to be equal to the weight downwards. which is going to be equal to m times g, or the sum of the two masses times g. So which will be the weight of the other one plus the weight of the other one. So it will be 0.2 times 9.81 plus 0.1 times 9.81. So what is this weight? Before, remember this is before or initially. So 0.2 times 9.81 plus 0.1 times 9.81. So this is 2.943. Okay, that is initial, that is the tension in that spring. Immediately after release, immediately after the thread is cut, so they are cutting off this thread. But remember, this is the initial tension, so it's going to be the initial resultant force upwards when they cut off the thread. Then, of course, it is going to decrease because this weight is going to go up off. What is the upward acceleration of the mass? What is the upward acceleration of the mass immediately? So it means here the immediate resultant force, the immediate F is going to be 2.943 newtons. That is the immediate F. But remember, this is going to be equal to mass times acceleration, and the only mass which we are considering here is now going to be 0.2. So it means the weight. So this is going to be the the force upwards, not the resultant force, but the force upwards. Immediate force upwards is going to be that, not MA. This is going to be the immediate force upwards when the thread is cut. Then the weight downwards is simply going to be now 0.2 times 9.81. I think this one is directly 1.962 newtons. So it means the resultant force F resultant, which is given by mass times acceleration, should now be 2.943, which is immediate, minus the weight downwards, which is 1.962. What is this? 2.943 minus 1.962. So this gives me 0.981 newtons. That is the resultant force immediately. That will be the resultant. So we want to find the acceleration. So MA is going to be 0.981. Of course, the mass is 0.2. So the acceleration is going to be 0.981 divided by 0.2. So divide by 0.2, I think that is 4.905 meters per second squared. So this means my answer is going to be A. A snowflake and a raindrop are in still air. They both fall from rest at the same time and from the same height. So H is the same and they're starting from the same time. The snowflake and the raindrop contain the same mass of water. So same mass of water. So mass is so they're saying mass is the same. Mass is the same. Assume that there is no evaporation or melting. Also assume that for a given speed, the drag force on the snowflake is greater than the drag force acting on the raindrop. Which statement about the snowflake and the raindrop is correct? Okay. So if we consider the raindrop and we consider the snowflake, they have the same mass. So the weight downwards is the same. The weight downwards is the same. But then there is a drag force upwards, and this is FD for the raindrop. Let this be raindrop. This is FD for the snowflake. This is FD for the raindrop. I'll use R for the raindrop. FD for drag force on the snowflake. So they have said FD for the snowflake is greater than FD for the raindrop. Which statement about the snowflake and raindrop is correct? The raindrop takes more time than the snowflake to reach terminal velocity. Remember, terminal velocity is got when the resultant force is 0, and the resultant force here will be weight minus Fd. And this means MA is going to be the weight minus Fd. And the terminal velocity is going to depend on the acceleration, or how long it takes to reach a zero acceleration. So because Fd is smaller, it means the resultant force here is going to be smaller. For the rainy drop here, because Fd is small, it means the resultant force here is going to be smaller, which also means the acceleration is going to be smaller. So it means this will reach, because the acceleration is smaller, it will gain a smaller terminal velocity, which can be reached very fast. Then, oh no, Fd is bigger for the, okay, Fd is smaller for the raindrop, so it means this is a bigger value. So if I compare the second one, MA is equal to W minus FD, let this be S, this is R. This value here is small, which means the acceleration is small. Because the acceleration here is small, it means also that the terminal velocity is small. A small terminal velocity is going to be reached in a very short period of time. A small terminal velocity is going to be reached in a very short period of time. So it means the rainy drop will travel a longer distance before reaching terminal velocity. Because the snowflake experiences more resistance, it will travel a short distance and reach terminal velocity very fast. So the answer to this question is going to be automatically A, which says the rainy drop takes more time than the snowflake to reach terminal velocity. Because there is a greater drag force on the rainy drop on the snowflake, it reaches it travels a shorter distance and the weight is balanced with the drag force. That means it will have reached its terminal velocity in a very short period of time. Yet for the rainy drop, because it has a smaller drag force, it will gain more speed before reaching a point where the weight is equal to the drag force, which means the rain drop will take more time to reach terminal velocity compared to the snowflake. Two trolleys are held together on a horizontal surface with a compressed spring between them. So that means here there is elastic potential energy to think of. When they are released, the trolleys lose contact with the spring. That means they lose their elastic potential energy. The spring loses its elastic potential energy, which becomes kinetic energy in the trolleys. The trolley of mass 2 kilograms moves to the left, so it moves to the left at a speed of 2 meters per second. How much elastic potential energy was stored in the spring? So first of all, let's first find the initial speed of the other trolley of mass 1 kilogram by conservation of momentum. Momentum is mass times velocity. So initially, the total moment, because this moves to this side with a speed of 2 meters per second, let me not even think of initially, because initially total momentum is going to be 0. So I'll say 0 is equal to, this moves to the left hand side. So let's say to the left it is negative. So this will be negative 2 times its mass, which is, its speed, which is 2, plus. We don't know where this one moves. So I'll just say plus. Its mass is 1 and let its speed be u. So it means u is going to be 4 meters per second. So If we set speeds to the right hand side are positive, so this moves to this side with a speed of 4 meters per second. If this moves to the other side with a speed of 2 meters per second. Okay, so I want elastic potential energy. Remember, it is the kinetic energy, the elastic potential energy, which became the kinetic energy. So I will say elastic potential energy is equal to the kinetic energy, which is going to be total kinetic energy. That will be a half times the mass of the first roll, which is 2, times its speed, which is 2 but squared, plus the second one is a half, its mass is 1 times its speed, which is 4 squared. So that is going to be 4 plus 16 over 2, which is 8, and this gives me 12 joules. So it means the elastic potential energy that was stored in the spring is 12 joules, which became the total kinetic energy in the two trolleys. A square board of side length x hangs freely from a nail P as shown. The board has uniform thickness and is made from material of uniform density. A second square board of side length 2x is made of the same material and has the same thickness as the original board. The second board is then hung from a nail Q. Nails P and Q are at the same height. Okay. What is the vertical distance between the positions of the centers of gravity of the two boards? So because nail P and Q are at the same height, then that makes my calculation very easy. If these ones are the same height, so I want to just find the vertical distance. So I will need to draw a vertical line here, and I will need to draw a vertical line here. So I will first draw the horizontal line here, and I'll also draw the horizontal line here. So I think it seems like this is the distance we are looking for. Let's see. What is the vertical distance between the positions of the centers of gravity between the two boards? Vertical distance between the positions of the centers of gravity um, between the two boards. Okay. So first of all, I will first find this distance here. I'll first call this one D1. Or let me just find the vertical distance of the center of gravity from one end, or maybe from the top, from point P. I'll call that distance D1. This one here. So this is a right angled triangle. So of course I'll just use Pythagoras theorem to find this and divide this by 2. So D1 is going to be Pythagoras theorem. So it will be x squared plus x squared under the square root, but this should be divided by 2. So this is going to be twice x squared under square root divided by 2, which will be x root of 2 divided by 2. Then I'll find also the distance from P to this point here. I'll call it D2. I'll first find the diagonal by Pythagoras theorem. Then I divide the diagonal by 2. So I'll say D2 is going to be the square root of a squared plus b squared. That is going to be 2x squared plus 2x squared. Then I divide this by 2. So this becomes 4x squared plus 4x squared. That is 8. X squared under the square root divided by 2. X goes out, then this will be 4 times 2, so it becomes 2x root of 2, 2x root of 2 divided by 2. So I want the difference, the distance between the vertical positions, so I'll just subtract. So the change in D is going to be 2x root of 2 over 2 minus x root of 2 over 2. So this is giving me only 1x root of 2 over 2. So I don't see this answer here, but if I do this times root 2 over root 2, so this becomes x root 2 times root of 2, it becomes 2x, I think. Then 2 divided by 2 root of 2, where this 2 cancels with that one, so I remain with x over root 2. So the answer is going to be automatically B. That's algebra, not physics. Forces are applied to a rigid object. The forces all act in the same plane, which diagram is the object in equilibrium. So in equilibrium, resultant moment should be 0, and the resultant force should also be 0. So we are going to be checking. Starting with A. A, the resultant force here, the resultant force is 0 because the downwards we have F, upwards we have a half F plus a half F. So F is 0. Then let's check the torque or resultant moment. F will have no moment above the center, but this will cause anticlockwise moment above the center. This will also cause clockwise moments above the center. Because they are all the same distance from the center, they cause equal but opposite moments, which make the resultant to be 0. So the answer is most likely going to be A. I can check B. B, the resultant force is 0, but the resultant torque, this one is pulling anticlockwise, this is also pulling anticlockwise, so the resultant torque is going to be anticlockwise. F and F have no moment above the center, but the other F at the extreme end cause the beam or cause the rigid body to rotate anticlockwise. This is wrong because the resultant force, so here we are saying the resultant force is not 0. I mean the resultant torque is not 0. So here resultant force is not 0, even though this would cause clockwise and clockwise, and this has no moment. Even though the torque is 0, the resultant force is not 0, it is actually F. This gives a resultant force of 0 because a half F plus a half F upwards, a half F plus a half F downwards, that is 0. But then the torque, this is anticlockwise, this is also anticlockwise, but this will be clockwise, and this one has no moment above the center. So it means there's a resultant moment which is anticlockwise. So this is not in equilibrium, not in equilibrium, not in equilibrium. It's the first one which is in equilibrium because the resultant force is 0 and the resultant torque is also 0. A rigid rod XY has negligible mass and length 75 centimeters. The rod is suspended from a fixed point P by a string attached to end X. An object of mass 11 kg is suspended by a string that is attached to the rod at the distance of 25 centimeters from end X as shown in the figure. Which vertically upward force acting on end Y of the rod would hold the rod horizontally in equilibrium? So the 11 kilograms is going to cause, this is a clockwise moment, so we need a force here which is most likely going to cause an anticlockwise moment to balance. So taking moments about P, I would simply say the clockwise moments or the anticlockwise moments, let me call this force F. So F times its perpendicular distance, which is 75 centimeters from the pivot, should be equal to 11 times, because this was mass, so the force here is 11 times G, which is 11 times gravity, that is mg. So it's 11 times 9.81 times the perpendicular distance, which is 25 centimeters. So I'll check my calculator. 11 times 9.81 times 25 divided by 75. So this is giving me 35.97. F is 35.97 newtons, which is approximately 36. The density of water is 1 gram per centimeter cubed, and the density of glycerin is 1.3 grams per centimeters cubed. Water is added to a measuring cylinder containing 40 centimeters of glycerin, so this is the volume of glycerin, so that the density of the mixture is 1.1 grams. Remember, total density of a mixture is equal to total mass of the mixture divided by total volume of the mixture. T is standing for total. And also remember, if I want to find the the mass of the water, I need the density of the water times the volume of the water. So let the volume of the water be W. The density of water is 1 gram. So this is going to be 1.0 times VW. So this is going to simply be VW. The mass of the water is equal to VW in grams. So total density is given by 1.1 equal total mass. Remember, it is going to be the mass of the water plus the mass of glycerin divided by total volume, which is the volume of the water plus the volume of glycerin. Remember, the mass of the water was equal to VW because I substituted the density times the volume. So this is going to be VW plus the mass of glycerin. Of course, for glycerin, the mass of glycerin is equal to the density of glycerin times the volume of glycerin, which is density is 1.3 and the volume is 40. So this will be plus 1.3 times 40 divided by the volume of the water, let it be VW plus the volume of glycerin, which is 40. So all I remain with is to solve this equation. So I'll say 1.1 times VW plus, I think this is going to be 40. If I'm cross multiplying, should be equal to VW plus, what is 13 times 4? I think this is plus 52. I hope I did this correctly. I said 1.1 times 40, which is 44. So collecting like terms, I'm collecting like terms, taking this one this side. I have 0.1 VW, taking 44 the other side. So taking 44 the other side, I think I did turn off the internet. So taking 44 the other side, it becomes 96. So I'm going to divide 96 divided by 0.1. No, it's not 96. You subtract 52 minus 44. That is 8. So I think VW is going to be equal to 80 when you divide both sides by 0.1. So the answer is going to be D. So that is 80. When I take this to the other side, a box in the shape of a cube falls from a ship into the sea. The box lands with its lower face level with the surface of the sea. So here we have the diagram. The box begins to sink, becomes totally submerged, and then sinks deeper into the sea. Now, when it begins to sink, of course, it's experiencing here, it has its weight downwards, it has the upthrust upwards. As the box sinks, its lower face is always parallel to the surface of the sea. Which graph best represents the variation of the upthrust? So remember, upthrust is equal to cross-sectional area times difference in pressure, which will be cross-sectional area, and the difference in pressure is going to be density times G times difference in height. This is going to be the height which is submerged. Delta H is the height which is submerged. So as H increases, when it is just, of course, H stands from, the change in height starts from 0. It starts from 0 before it starts being submerged. And remember, upthrust is going to be directly proportional delta H. So this is going to be a straight line. The upthrust is directly proportional delta H, or the height submerged. So it's going to be a straight line, which means it starts as a straight line. But remember, when it is fully submerged, the upthrust depends on the pressure on the top and the pressure at the bottom, and this is going to be the delta H. So if it is fully submerged, delta H is going to remain constant. It means the upthrust reaches a point when it becomes constant. So initially it increases. So this is initially increases, then becomes constant, because delta H with the time becomes a constant. So this one is showing it increases indefinitely. This one shows it is constant. The answer is going to be C because initially here, upthrust is directly proportional to the height H. Then this one is showing that when the box is fully submerged, the change in height submerged is constant. So here delta H is, the depth is constant. When the depth remains constant, the upthrust also remains constant. So the change in height remains constant, so the upthrust remains constant. Even if it moves deeper and deeper and deeper, it is depending on the difference between the top and the bottom of the object, which is going to remain constant. So it is not depending on how deep the object is, not at all, because the difference in the pressure on the top and the pressure on the bottom remains constant when the object is fully submerged. But before the object is fully submerged, as more and more height of the box is submerged, the difference in the pressure increases. So the upthrust increases. But as soon as it is fully submerged, then the difference in the pressure on the top of the object and the bottom of the object remains constant. So the upthrust remains constant. So the answer is going to be C, and it will not be D. D is wrong because here it is supposed to be a straight line since upthrust is directly proportional to delta H. A spring is compressed by a mass as shown. Which statement describes the changes to the energy of the spring when it is compressed by its mass, by the mass energy of the spring? Of course, when it is compressed, it goes downwards. The elastic potential energy increases because the compression increases. But then gravitational potential energy is going to decrease because this one depends on mgh. The h is decreasing, the vertical height is decreasing, so it decreases. But elastic potential energy depends on the compression. The compression is increasing, so it means the elastic potential energy increases. So this one automatically means the answer is going to be the spring gains both. It doesn't gain gravitational potential energy, it instead loses it because the vertical height decreases. The spring loses both gravitational potential energy and elastic potential energy. It loses gravitational but doesn't lose elastic because elastic is depending on the compression. A half k x squared, where x is the compression. When it is compressed more, the compression is increasing, more elastic potential energy is stored. So the answer is going to be D. The spring loses gravitational potential energy but gains elastic potential energy, that is by conservation of energy. A man of mass 75 kilograms runs up a stair consisting of 30 steps. Each step is 20 centimeters. Okay, so I can find the vertical distance already. The vertical distance will be 20 times 30, which is I think 600 centimeters, which is 6 meters. The man takes a time of 7 seconds to run from the bottom of the stair to the top. What is the average rate of increase in the gravitational potential energy of the man? So this is like power. So average rate of increase in gravitational potential energy is going to be mgh over t. So this is going to be the mass 75 g 9.81 times the h, which is 6, divided by the time, which is 7. So have 75 times 9.81 times 6 divided by 7. So this is 630. 630. So it is 630 watts or joules per second. An alpha particle has 2.2 times 10 to the power of minus 13 joules of kinetic energy. What is the speed of the alpha particle? Of course, we know that an alpha particle is a helium nucleus, He42. So it means it has mass of 4u, which is the same as 4 times 1.66 times 10 to the power of minus 27 to change it to kilograms. So kinetic energy is a half m v squared, which means the speed v is going to be the square root of twice kinetic energy divided by m. So I'll say the square root of 2 times 2.2 times 10 to the power of minus 13 divided by the mass. The mass is under the square root also. 4 times 1.66 times 10 to the power of minus 27. So 2 times 2.2 exponent minus 13 divided by 4 times 1.66 exponent minus 27 square root of the answer. So this is 8.1 times 10 to the power of 1, 2, 3, 4, 5, 6. Okay, so 8.1 times 10 to the power of 6, which makes the answer to be C. Identical springs are joined in 4 arrangements. Which arrangement has the same spring constant as a single spring? Okay, so this is the formation of solids, I guess. So let's start with these two. For springs in series, total extension is the sum. If I have one spring, let's have first of all one spring. If I attach the load, it extends by extension E. So let's say total extension is E, and total constant is K. Now if there are two in series, this is E, this is E, it means total extension is going to be twice E. Of course, total constant will be the reciprocal of the coefficient, which is 1 over 2 times K. So that means this is not true. Then here, if one spring extends by E, when you use them together, the extension reduces by a half. So here, total extension is going to be a half of just one. It's like they share the load, so they extend less. If you use it alone, it extends by E. When you use them together too, the extension reduces by a half. Which means total constant here is going to be the reciprocal of the coefficient, which becomes 2 over 1 times K. So this is also out. So here we have each of these would extend by extension of this side would be 2E, this side would be 2E if you were to use it alone, but now they are used together. So if they are used together, 2E and 2E, when you use them together, total extension becomes half of the extension of one system. So it is half of 2E, which is going to be E, which means total constant is going to be the reciprocal of the coefficient in front of E, which is a 1. So it is going to simply be K. So the answer is going to be C. Because the question is which arrangement has the same spring constant as a single spring? So the answer is going to be C. I will not check D, but I can still check D. So if I have one, these two are in parallel. If it was one, it would extend by E. Now that they are two, they would extend by a half E, but this is alone, so it extends by E. So now there are two springs in series, so a half E plus E. This will give me a total extension of 3 over 2E. That means the total constant will be the reciprocal of the coefficient, which will be 2 over 3 times K. So it means this is also not correct. An unstretched spring has a length of 2.0 centimeters. The spring is then stretched within its limit of proportionality by a tensile force of 1.5 newtons, so that the elastic potential energy stored in the spring is 0.045 joules. What is the stretched length of the spring? So of course we know that elastic potential energy is equal to a half times the force times x. So I want to make x the subject, so x is going to be twice E divided by, I think, F. So this will be 2 times the elastic potential energy, which is 0.045 divided by F, which is 1.5. Okay, so this gives me 2 times 0.045 divided by 1.5. So this is 0.06 meters. So I didn't need the original length. Oh, sorry, I need the original length. So this is going to be 6 centimeters. The question is, what is the stretched length? So I need to add the original length plus the extension. So the stretched length is going to be 6, or 2 plus 6, which is going to be 8 centimeters. So the answer is going to be D. It is the original length plus the extension. A signal generator, amplifier, and loudspeaker are used to produce different sound waves in the air of a room. The relationships between the properties of these waves are investigated. Which relationship is not correct? You have signal generator, amplifier, and loudspeaker are used to produce sound waves. So which relationship is not correct? The amplitude is proportional to wavelength. This statement is not correct. We know that intensity is directly proportional to amplitude squared. And we also know that, of course, the amplitude is inversely proportional to the square of the distance from the source. So that means the first statement is not correct. Frequency is inversely proportional to wavelength. That is correct because V is equal to lambda times F, which means if V is constant, F is inversely proportional to lambda. Intensity is proportional to amplitude squared. That one I've already mentioned it here. Period is the reciprocal of frequency. We have already seen F is equal to 1 over T. So it means the first statement is the one which is not correct. When a guitar string is plucked, it causes a longitudinal sound wave in the air as shown in the figure. The speed of sound in the air is 340 meters per second. What is the approximate frequency of the sound wave shown? Okay, so I'll first find the wavelength. I'll say distance from between two successive compressions. I think this is 5 meters, 0.5 meters. So I want frequency, V equals lambda F. So F is going to be V over wavelength. V is 340, then wavelength is 0.5. So 340 divided by 0.5, that is 680. So the answer is going to be B. The transverse wave travels along a rope. The diagram shows the rope at time t equals 0. The wave is traveling from left to right. So it's traveling like this, which means particles on this side must be vibrating upwards. A particle here is going to be at rest, but turning to, the next particle was vibrating upwards. After this particle here, particles on this side must be vibrating downwards. A particle here must be at rest. At this point here, the particle must be at rest, or it has reached the highest maximum displacement, so it's temporarily at rest. Okay. One particle of the rope is labeled X, which graph shows the variation with the time of the displacement of particle X between t equals to 0. Of course, t equals to 0, it is passing equilibrium, so the displacement is 0. So at t equals to 0, the graph should start from 0, which means I eliminate C and D. Because this is a horizontal line through the wave, at t equals to 0, it is passing equilibrium. Okay? But then the particle was vibrating downwards, so it means the graph should start by going downwards. So it is, because the arrow is pointing downwards, means it was being displaced downwards. So it means the answer to this question is going to be B. The displacement time graph should be at the bottom, start from the bottom, because the particle here was vibrating downwards. If the wave was from right to left, the graph would be A. But since it is from left to right, the graph is supposed to be B, because at point X, it was passing equilibrium but vibrating downwards. So it means the displacement is downwards. So the answer is going to be B. A jet aircraft travels at the speed of 0.80 V, where V is the speed of sound. The aircraft directly approaches a stationary observer. The frequency of sound emitted by the aircraft is 100 Hz. Which frequency does the observer hear? So it is approaching. So if it is approaching, then of course we know that the observed frequency F0 is equal to V over, because it's approaching, we subtract. So it is V minus 0.80V. Then we multiply this by the natural frequency, which is 100. So V has cancelled. So it is, yes, it is 100. V has cancelled. So I have 1 over 1 minus 0.8 times 100. So 1 divided by 0.2 times 100, which gives us 500. So this is going to be 500 hertz. Remember I said that there is a minus here because it's approaching. If it was moving away, it would be a plus, because approaching means a higher frequency. So if it was moving away, it would be plus. But since it is approaching, this is going to be minus. A telescope detects and analyzes some electromagnetic radiation of wavelength 2 centimeters. I think 2 centimeters is 0.02 millimeters. I think this is microwaves, if I'm not mistaken. Which type of telescope is it? Automatically, this is microwaves, because for radio waves, remember Rumenera's mother is visiting Uncle Xavier's garden. So for radio waves, it starts from 10 to the power of 4 to around 0.1 or 0. It should be 1 decimal place. Then followed by microwaves. Infrared is around 10 to the power of minus 5, so this can't be infrared. Visible is 10 to the power of minus 7, so it can't be visible. So the answer is going to be A. Two waves of the same type overlap, same type. What does the principle of superposition, when does the principle of superposition apply? Of course, the principle of superposition always applies as long as the two waves overlap. The resultant displacement is the algebraic sum of the individual displacements. So whether they have the same amplitude or not, it always applies. Whether they have the same frequency or not, the principle of superposition always applies. It may not result into constructive or destructive interference, but the principle of superposition always applies. A stationary sound wave is formed in a tube of length L that is closed at one end. The diagram shows the positions of the nodes and antinodes of the stationary wave. So this is an antinode, so I can sketch this. And this is another antinode, I can do this. So if I want to sketch a graph of displacement against distance, I can take the upper part or I can take the bottom part. Let's see the question. Which graph shows the variation of amplitude A of the wave with the distance x measured from the closed end of the tube? So we are just considering, we are measuring from the closed end. So if we measure from the closed end, so at the closed end, the amplitude is 0. Then as we move towards the center, the amplitude reaches a maximum displacement. Reaches maximum. Then we reach somewhere here, we reach a node where the amplitude goes to 0. Then again, it goes to maximum. So this is automatically going to be wrong. We only have two antinodes. That is wrong. This is also going to be wrong because it is representing a wrong position for a point where the amplitude is 0. So we have to choose between A and B. B is automatically going to be wrong because B is showing that the amplitude has changed direction, yet it won't change direction. If I measure the amplitude I will not be able to detect a negative amplitude. So I'll just see a 0 amplitude, maximum amplitude, 0 amplitude, maximum amplitude. So I will not detect a negative amplitude. So the answer is going to be automatically A. A wave on the surface of water passes through a gap between two barriers and is diffracted as shown in the figure. What happens when the frequency of the wave is halved? So frequency halved, this means the wavelength lambda is multiplied by 2. So the wavelength is doubled. So if we double the wavelength, I'll measure this distance here and compare with this one here. So here we notice that, let's say this distance is d. We are seeing that d is equal to twice of wavelength here. So if we double the wavelength, it means when we have the frequency, we double the wavelength. And when d is approximately equal to twice the wavelength, diffraction is maximum. So diffraction is maximum if the wavelength is very close to the size of the gap. So by halving the frequency, making the frequency half, we double the wavelength. When we make the wavelength to be twice than the one which we had here, it means we are making the wavelength to be the same as the size of the gap. So if the wavelength is the same as the size of the gap, diffraction is maximum. So let's see, less diffraction is observed, more diffraction is going to be observed. So I think more diffraction is observed. In fact, diffraction is maximum if we make this to be the wavelength, which is the same as the size of the gap. We expect more diffraction. So diffraction is maximum when the wavelength is the same as the size of the gap. Observable interference fringes are produced using light from a double slit. The intensity of the light emerging from each slit is initially the same. The intensity of the light emerging from one of the slits is now reduced. So intensity from one of the slits is reduced, which means total intensity decreases. Total intensity decreases. If total intensity has decreased, it means the brighter fringes are going to be less brighter. The brighter fringes must be less brighter. That one should be the guiding point. So brighter fringes and dark fringes all become brighter. That is not true because the brighter fringes will be less brighter. The brighter fringes and darker fringes all become darker. Also remember, by the way, intensity is directly proportional to amplitude squared. If the intensity in one of the light is reduced, it means the amplitude is no longer the same. A, not the same. So we don't have total cancellation. No total cancellation again occurs, which means the dark fringes will no longer be dark because there is no total cancellation. So this means my answer is going to be automatically D. The bright fringes become dark or they become less brighter because total intensity has decreased. The darker fringes become brighter because we no longer have total cancellation. Since the amplitudes are no longer the same, let's say you have two sources of light. The amplitude here is now, because the intensity, let's say initially it was 2, 2. Then now you have here 1, 2. So here total amplitude is 4. Here total amplitude is 3. But for cancellation, total amplitude here will be 0 because it will be 2 minus 2. Here for cancellation, total amplitude will be 1. So here we don't have total cancellation. So the darker fringes will not be dark. They will instead become brighter. But since total intensity changed from 3 to 4, total amplitude reduced from 3 to 4, it means the brighter fringes are going to be less brighter, or we say they become darker. So the answer is going to be D. A diffraction grating has 4 times 10 to the power of 5 lines per meter, so this is capital N. A beam of light wavelength, so this is lambda, is normal on the diffraction grating. What is the angle between the second order maximum and the direction of the incident beam? So we want, this is small n equals 2, and we want to find theta. Okay, so for diffraction grating, we are all aware that n lambda is equal to d sine of theta. So which means theta is going to be the sine inverse of n is 2, the wavelength is 589 times 10 to the power of minus 9 divided by d, which is, of course we know that d is 1 over n. So it will be 1 divided by 4 times 10 to the power of 5. So this one goes up. So I'll say 2 times 589 exponent minus 9. Just multiply this by 4 exponent 5. Then I'll say sine inverse of the answer. So theta is going to be 28.1 degrees. So the answer here is going to be C. Electricity length of wire RS has a cross-sectional area, has a circular cross-section here. At end R of the wire, the cross-section area is A. At the other end, it is A over 2. Charge Q takes time t to pass through end R of the wire. There is a constant electric current in the wire. Of course, they are in series, so the current is the same. Section R and S are in series, so current is the same. How much charge will pass through end S in a time t, in a time interval of t over 4? So let's say the time at t equals to 0, we are at R, and t equals t over 4 is we are at S. Okay. So I know that current equals to N A Q times the drift speed. So this side, on the other end, I will say N times the cross-sectional area is A times the drift speed. This side I will call it VR, then times NAVR, then times let the charge this side be small letter q. I'm considering small charge q. Then the other side, of course, the current on the other side should be the same as the current on the other side. So I'll just say equals to, I'm saying I on R is the same as I on S. So on the other side I have N, cross-sectional area is A over 2. The drift speed there is going to be Vs. Of course, the charge of a particle is Q. So Q cancels, N cancels, A cancels. So it means Vs, the drift speed on S, is equal to twice the drift speed on R. That's number one. Number two, I'm going now to consider total charge. Total charge this side is going to be Q on R is going to be I. Let it be capital Q, and it's going to be I times the time t, which is going to be, the current is N A Q VR times t. So total charge Q is equal to that. When I make VR the subject, it means VR is going to be equal to total charge Q divided by N A times the charge of each charge carrier, then times T. Okay. If I try the other side S, so QS is also going to be, and the area, remember, is A over 2, so it will be A over 2 times the charge of each charge carrier, which is Q, times the drift speed, which is Vs, times the time, the time that side is going to be T divided by 4. If it is T the other side, this side is T divided by 4. Okay, so it means QS is going to be equal to, this will be N times A over 8 times Q. Where there is Vs, I'm going to put there twice VR. Vs is twice VR, so I'll say times twice VR, then times T. Okay, I'm trying to simplify. So it means QS is going to be equal to NAQ divided by 4 times VR times T. So I'm going to just factor out this. Remember, I want the charge at S, that is QS. So I just want VR. Remember, VR is Q over NAQT. So I'm just going to substitute. So QS is going to be NAQ over 4 times T times VR, which is Q over NA small q times T. NA small q times T cancels out and I remain with the Q over 4. So if the charge on the other side is Q, the other one is going to be Q over 4. So the answer is going to be B. If you're good at mathematics and relations, you don't even need to do all this. A power supply is connected to a component by connecting wires of total resistance 4.9 ohms. The power supply has an output of 3.6 watts and terminal potential difference of 12 volts. So that is V. How much thermal energy is dissipated in the connecting wires in a time of 1 hour? So I can first of all find the current, because I know power equals to I times V. So this means the current is going to be 3.6 divided by the terminal PD, which is going to be 12. I think this is automatically 0.3 amperes. Okay, that is in the, I used PD across the terminal PD and the power dissipated. The power supply has an output power of that. Okay. I'm assuming the internal resistance is negligible. So the energy which is dissipated is going to be the power times time, which power is going to be I squared R then times T. The current is 0.3 squared times R, which is 4.9, then times T, which is 1 hour, which is going to be 3,600 seconds. That is 1 hour. So 0.3 squared times 4.9 times 3,600. So this is 1587.6, which is approximately 1.6 kilojoules. So the answer is going to be C. A copper wire is to be replaced by an aluminium alloy wire of the same length and resistance. Copper has half the resistivity of the alloy. What is the ratio diameter of the wire over diameter of copper? So remember, resistance is equal to rho L over cross-sectional area, and also remember that the area is pi d squared divided by 4, which means our resistance R is going to be equal to, the 4 goes up, rho L over area. So they said same length, same resistance. So I'll equate equations for resistance. The resistance of copper is the same as the resistance of the alloy. So for copper, I would say 4. Copper has half the resistivity, so I'll put a half here. So I'll say rho over 2. Then length, they have the same length, so I'll say times L. Divide by pi. Diameter, so I will say diameter of copper, I'll call it d subscript c squared. This should be equal for the alloy, it will be 4. Its resistivity is rho. They have the same length, pi, and the diameter of the alloy, let it be dA squared. So pi cancels, 4 cancels, rho L cancels. So I have to take dA up. I have 1 over 2 dC squared is equal to 1 over dA squared. So when I take this one the other side, I have that dA over dC, but this is squared, is equal to 2. So I get the square root of both sides. So dA over dC is equal to the square root of 2, which makes the answer to be A. 3 identical filament lamps, P, Q, and R, are connected to a battery of negligible internal resistance. The filament wire lamp Q breaks so that it no longer conducts. So note that the PD across Q was the same as the PD across P because they were in parallel. That's number 1. But then, if one of them breaks, Remember, the advantage of having resistors in parallel is to make the resistance smaller. So if one of them breaks, it means the power resistance has been reduced, which means total resistance increases. R total increases. And if R total increases, it means total current supplied by the battery goes down. So remember, R was having a fixed resistance and it had a certain PD, which could have been higher or lower than the others, but because the current going through it has now gone down, the PD across R goes down. So PD across R decreases because the current going through it is now smaller. And if the PD across this one decreases because the current going through it is smaller, by conservation of energy, the PD across P increases. So PD across P increases by conservation of energy. So what are the changes in the brightness of lamps P and R? Of course, R may slightly become less brighter as P becomes slightly more brighter, as simple as that. So P becomes brighter and R becomes dimmer. So the answer is B. I have just explained this. Having resistors in parallel means we reduce total resistance, so there is more current. But when Q breaks and it goes out of the circuit, total resistance becomes higher, which means total current in the circuit decreases because the EMF has not changed, and yet the current is equal to EMF divided by total resistance. Total resistance has increased because the one which was reducing the resistance has blown out. So total resistance increases, total current decreases. That means the current which goes through R, which was in series with the battery, decreased. That means the PD across R decreased, which means by conservation of energy, the PD across P increased. So P becomes brighter as R becomes dimmer. Which ratio has the same units as EMF? Remember, EMF is defined as energy converted from chemical to electrical per unit charge. So that is per unit charge. Energy converted from chemical to electrical per unit charge. So that is energy transferred per unit charge, which makes the answer to be C. A circuit consists of a battery, a voltmeter, and 5 fixed resistors as shown. The voltmeter reading is 0. What is the resistance of R? Okay. So for such a circuit, I'll just use the crisscross relationship. So for the crisscross relationship, the product of these, if the voltmeter across reads 0, it means the product of these should be the same as the product of these resistors here. And remember, these ones are, this is a branch which is in parallel, so I'll call this one R in parallel. So I'll say 5 times resistance in parallel should be the same as 5 times resistance in parallel 5 times resistance in parallel should be the same as 2 times um, 2 times, so this is 5 times resistance in parallel should be the same as 2 times 10. So it means the resistance in parallel is going to be equal to 20 divided by 5, which is 4 ohms. But the resistance in parallel, we have R times 8 over R plus 8. This should be equal to 4. So it means have 8R equals to 4R plus, I think that is 32. So then this is going to be, is it 4R equals 32 by 4, which gives me R as 8 ohms. So this is going to be 8 ohms. I first use the crisscross relationship, then I considered the two resistors 8 and R in parallel, so the answer is D. A battery of EMF 6 volts and negligible internal resistance is connected to a voltmeter and 4 other components as shown. The voltmeter is connected between points X and Y. The positive terminal of the voltmeter is connected to X, and the negative terminal of the voltmeter is connected to Y. Initially, the resistance of each of the 4 components is 1 kilo ohms, which means the PD here is 3 volts. It is 3 volts. It is 3 volts. It's 3 volts. So the voltmeter will read 0. Which change on its own will cause the voltmeter to show positive reading. So it should have high potential here and low potential here. So it means the PD across the P potential at this point should go down. The only so I'm saying initially V is equal to 0 initially before we make a change. But for the voltmeter to show a positive potential, it means potential at X should be greater than potential at Y, because the X is where the positive terminal is connected and Y is where the negative terminal is connected. So for this to happen, then we should reduce the potential at Y. The only way we can reduce the potential at Y is by ensuring that the PD across the thermistor decreases. So PD across the thermistor should decrease. And if the PD across the thermistor decreases, it means the PD across the LDR should increase. And how does the PD across the LDR increases? For the PD across the LDR to increase, its resistance must increase. So resistance of the LDR should increase. And if the resistance is to increase, then the light intensity must decrease. So I said potential at X should be greater than potential at Y. That's number one. Number two, we want for potential at Y to be smaller, we must reduce the PD across the thermistor. We reduce the PD across this part here. So to make the PD across the thermistor smaller is the same as making the PD across the LDR higher. Remember that conservation of energy. Total should remain 6. And if I make the PD across the LDR higher, it's because the resistance across the LDR increases. The only way the resistance of the LDR increases is when the light intensity decreases. So this means the answer is going to be C. Reduce the light intensity incident on the light-dependent resistor. An alpha particle passes close to a gold nucleus and is deflected through an angle greater than 90 degrees. Which property of the alpha particle changes as a result of the deflection? Of course, when the angle is changed, of course, it's the velocity will now have components, which means the momentum will be changed. The charge remains positive 2e, nucleon number remains 4, proton number remains 2. So it's only the momentum which is changed, because momentum depends on the direction. It is a vector quantity. A nucleus of uranium-238 decays in stages by emitting alpha particles, beta minus, eventually forming a nucleus of lead. So we have uranium-238 92. It is giving us lead, which is 20682. It is giving us alpha, that is 42. It is giving us beta minus, which is 0, -1. Let's say it is giving us X alpha particles and Y beta particles. How many alpha particles and how many beta particles are emitted? So I will start with the alpha particles. So I have 28, 238 is equal to 206 plus X times 4, that is 4X, plus Y times 0, that is 0. So what is X here? So X is going to be 238 minus 206 divided by 4. So X is going to be 8. So X is 8. Then I will say again 92 equals to 82 plus x times 2, which is 16, because x is 8. Then plus y times -1, which is minus y. So I have 92 minus 82 minus 16 divided by -1. So y is equal to 6. So alpha particles are 8, beta particles are 6. So the answer is going to be A. And lastly, which list of particles contains only fundamental particles? So the answer is automatically D. Here, this one disqualifies because the meson has quarks. It has quarks in it. So baryons have quarks. So fundamental particles are not made up of anything simpler. Alpha particle has quarks. The lepton has no quarks. A quark is the smallest particle which makes up others. Positron has no quarks, so the answer is going to be D. Okay, so that marks the end of 1-1. See you in 1-2. Until next time, bye-bye.